I'm Patrick Arlt. I work on the ArcGIS for Developers website. This is the 4th year running for CSS for Geographers. This is part of the little intro series on just some basic kind of programming concepts to kind of get you started on various things. That slide URL is going to reappear at the end, so don't get too nervous. This is a really fundamentals talk. We're about styling web pages. The goal is to kind of get you the knowledge that you need to have moving forward when you build websites. I just came from JavaScript for Geographers, where we talked about kind of the JavaScript part of building web pages. This is all about the styling of web pages and trying to break that down as much as I can for you. So there's that slide URL again. It's going to come back at the end. These slides are really constructed as kind of a learning resource. There's links to tons of demos. There's links to tons of supplemental info that I'm not going to go over. It's designed as kind of a reference for you to use later. There's tons and tons of links throughout this. So in comparison to JavaScript, CSS is sometimes really hard for a lot of people. And a lot of that has to do with maybe it's closer a bit more to art and design than it is to kind of a GIS or computer science. And it requires knowledge and kind of domain expertise of both kind of design, how do I make things look good, and development, how do I actually program them that way. And there's a lot of kind of unintuitive like tricks and things that browsers will play on you. And it takes quite a long time to get to a super proficient level. And then sometimes browsers will change or a best practice will change. And that happens not nearly as frequently as JavaScript, but there's seen some shifts in the last couple of years that make CSS even more efficient, but it's required a few changes. But once you get to that point, you can do a lot with CSS. You can customize all of those built-in Esri apps, the story maps, the configurable apps, web app builder apps. You can get started with CSS frameworks. You can build and lay out web pages for your city or your, group of friends. You can build apps with this. It's a super good skill to have if you want to make that presentation, that web app a little bit better for the mayor or your boss. It's super handy to have. So I want to go over a couple basics. Where do we put CSS? CSS can go in a couple places. You definitely you can put it inside of a style tag on your HTML page and just put CSS inside a style tag. You can also put CSS in a separate file. You just .css it, and then there's a link tag. It has an href that points to that style. It's got a style sheet and it's of type text CSS. That's just a real quick one. And both of those you should put in the head tag of your HTML files. That's where CSS belongs. Now, an individual bit of CSS, you've probably seen this quite a lot if you've ever looked at a JavaScript API sample. So I'm going to break down exactly all the parts of this little bit of CSS. So we've got HTML, body, hashtag map, and then we've got some brackets. So we have margin 0, width 100%, height 100%. So the first part of that is called the selector. And the selector finds things on your HTML page to work on. And you can separate multiple things with commas. So in this case, we're finding 3 elements on our web page. We're finding everything that's an HTML tag. We're finding everything that's a body tag. And then we're finding whatever has the ID of map. That's what that hashtag means. You've got a pair of brackets. Once you've got a pair of brackets, this is a CSS declaration. That's the fancy word for it, but it's a pair of brackets. And then you've got a property. So in this case, the property on those things, the body, the HTML, the map that we want to modify is the margin. And then you set that to a value. In this case, we want margin to be 0. And then you kind of continue. We also want the width of this to be 100% wide. And we want the height of this to also be 100% high. And what this does is this actually just sets the map up to be full screen. This is the shortest sample that you can do that in. And when all those things are complete, you have what's called a CSS rule. And this is a single rule. And you'll have hundreds or maybe just a couple dozen rules in your average CSS file. But how does that actually work? And this is about the C in CSS, which stands for cascading, and that's how the browser builds the final style to apply to an object. Because you can have things from different CSS files, and you can have things from style tags and scripts, and all sorts of stuff can impact the final style that the browser actually uses to actually style the object. So this is actually what a typical cascade looks like. This is kind of your average web page. The browser has a default style that it ships with. It styles H1 tags to be bigger than H2 tags, and it puts a little bit of space around paragraphs and things like that. Then as a user, you might define your own style sheets. Maybe you have slight dyslexia and you want everything to appear in a font optimized for that. That's a user style sheet. Then you might include a bunch of style sheets with link tags. You import a bunch of other CSS. Then you put some CSS and some style tags. And then maybe you put CSS inline with some of your HTML elements. All of those things accumulate those CSS rules that apply to the elements. And that's when you get into specificity. If I have something that says, I want the background of this button to be blue, and something else says it should be red, how does the browser pick if it should be blue or red? And that's when you get into specificity. So the most specific rule is the rule that's applied. And it generally looks like this. Any rule that you mark as important is always the rule that wins. That's a pretty simple one. But you don't really want to do that, because if you want that button to be purple later, you can't override the important rule, and then you're stuck. Anything that you do with an inline style is going to be next. Anything that you put in a style or a link tag, and then a concept called selector specificity. And that says the most specific rule wins. So the most specific rules are ID rules. So in the case of that ID map, anything that we put in there would probably win. Then anything with a class, like div class foo, and then anything with a tag, like just style every div. And there's a neat little tool that I've linked here called CSS Explain, if you want to play around with that. This gives you a nice little interactive, which is the most to least specific. So you can see that if I type in ID map, I've got a very high specificity of 1. And if I do dot button red, I've got a slightly lower specificity because I've only got 2 in that second box right there. And then finally, you can maybe say all paragraph tags only have 1, and that's a tag. But if I do p.red, then I've got 1 in each of those. So that gives you just, it's a fun little interactive app to kind of explain some of those CSS rules. So in a tie, the last rule wins. That's the final tiebreaker. Whichever one you declared last is always the winner. So how does this actually look in practice? So we're going to take a look at a little story map that I've got loaded up. This is just one that I pulled off the Story Maps website. And the easiest way to get started with CSS is just right-click in your browser and hit the Inspect Element button. And that's going to pop open DevTools. And we don't need the console. And it's going to just, you're going to hit an element on the page that'll be selected. So in this case, I've got this H1 element selected in DevTools, and I can see that it has class of cover title, and it's also got title text, and it's also got text gray. And if I look at the styles, these are all the CSS styles that are being applied to this one H1 tag. And they operate in the order of the cascade. So the most specific thing that's telling this to be a particular style is this CSS rule, which is telling it to have no text shadow. And that's overriding this rule, which is telling it to have a text shadow. And then you can see the same thing happen for color. This is telling it to be black. This is telling it to have a font size of 5M, which we'll get into. This is telling it it can be no wider than 100% of the width of its container. And you can look at this computed side over here to see what the final style is that was applied to this H1. But the best part about DevTools is you can also type in your own styles, and the easiest way to do that is up in this element. So we can say something like color red, and you can just start seeing what it would look like if you applied different CSS styles. So we can maybe say background. No, let's actually go with hot pink, and then we can make that white. So you can actually see that you can just start playing around with CSS in your browser, just load up any web page and start seeing what they do in their CSS. And this is also excellent for previewing things without actually bothering to edit them. So that's another way that you can do that. So what are we going to do for the rest of this session? I've been talking up here for 10 minutes or so. We're going to actually build this little app. I'm going to style it from start to finish. We're going to look at some core ideas of CSS, and then we're going to actually apply those and lay this app out. So the first concept I want to talk about, this is the most basic building block of CSS, is every element in the browser, every paragraph, every div, every anchor, every button, every form input, is either a block or an inline. And those are two different ways that the elements get laid out. So block elements are building blocks of layout. They always expand to fill their container in the width category, and they're always as tall as their content, kind of by default. And you can specify different widths or heights for them. So in this case, I have a bunch of divs, and they all have different things. I'm a block element, I have width, I have height, and we have a bunch of CSS rules that apply to them. So all of our block elements have these rules applied to them. So they're all cyan backgrounds with green borders and things like that. So block elements are going to fill the width of their container, and they're going to be as small as their content is high, but you can also override that, as you can see with these two that specify width and height. So the I have width one, which is this one right here, has a width of 250 pixels. So it's 250 pixels wide, and it's always going to be 250 pixels wide no matter what I put in it. Same for this I have height. It's always going to be 260 pixels tall no matter what I put in it. Now, comparing that to inline elements are how you deal with text usually. Inline elements flow like you would read them. And they have a few special properties. One is this white space property, which tells them how to lay out white space. Do I preserve it exactly like I typed it into the browser? Do I let it wrap? Do I break on hyphens? Do I break on spaces? Usually you just leave it as the default. And they also ignore margin. If you tell it, I want this line of text to be 10 pixels away from the closest thing to the top, it just ignores it because it's text. It's supposed to flow. It's not supposed to be used for layout. It also ignores height, and they ignore width. But you can apply padding to them. This is good for buttons. And you can apply borders and backgrounds and other fancy things to your inline elements. And I'll have to make this a little larger. They're also subject to a different property, which is vertical align, which tells it where do I align this vertically in space. This is great for writing out things like equations where you might need exponents or things like that. Where do I want this to align? Do I want it to align in line with the other text? Do I want it to be above it, below it? Things like that. So just a little demo as we go through block and inline. That's kind of the two basic building blocks. And these are some of the links I mentioned. That's more links about the same topic. I'm not going into that. So let's talk about units. CSS has a lot of different units of measurement. The most common one we can see is 200, this box is 250 pixels square. And that's fine. That's pretty easy to understand. It's 250 pixels wide, and it's 250 pixels tall, and it's always going to be that way. This box is 25% wide by 25% tall, but something's kind of curious. It's clearly not 25% tall, but as I make this larger and smaller, you can see that the 25% wide works. And what should this box be 25% the height of? There's really no good way to measure that. So browsers just choose to ignore it. If the parent of something doesn't have a fixed height, it can't calculate 25% of it, because essentially you're saying it's 25% of kind of whatever the height of everything is. But then if it's 25% high of that, doesn't that change the height of everything? And then it just keeps going and going and going, and it's going to be infinitely tall. So they just ignore it. Next, there's a unit called ems. And an em is always a relative unit. It's relative to the text size of that element. So if I say that this font size of this .m class, which is right here, is 10. So the font is going to be 10 pixels. 10 ems is 100 pixels. So if I change the font size, I also change the width and height of the box. And that's useful for things where you might want to make part of the page larger, and you can use that as a relative measurement. So if you have a button and then you have a button large and you always want a certain amount of space to be around that button, as you make the text size of the button larger, you're also going to scale up the other aspects of that button. There's another unit called rem. Rem is just root m, which is always relative to the size of the body. The body in almost every browser is always 16 pixels. And you can see I set it to 16 pixels by hand up here. So 10 rem is always going to be about 160 pixels. And that's relative to the root of the browser. So if I change this to, say, 24 pixels, all my text gets larger. This box also got larger, but this box didn't, because it's still 10 pixels on this particular box. And then the last two are VH and VW. And VH and VW stand for viewport height and viewport width. And that's actually relative to the size of the window that you're looking at the page on. So if I make this wider, you can see that this box gets wider because it's always taking up 25% relative to the size of my screen. And if I could make this taller, which I can't because I'm in JSBin, that would make that div taller because it's 25 VH by 25 VH. It's always going to take up 25% of the height of my screen. And that'll come in handy a little later. So how do we actually start laying these out? We know that we can make things certain sizes, and we know about block versus inline. How can we actually start laying out a web page? Now, the easiest way to lay out a web page is with something called floats. Now, a float just says, take this element and align it left or right. Pretty basic. In this case, we have three divs. We have a div, we have a body, we have a sidebar, and we have a map. Our map floats right, so we take our map, we put it on the right side of our page. That map is 70% the width of our page. And then for the sidebar, we float it left. It's 30% wide. Both of them are 100% high. The height of the body is 500 pixels, so you can see it's 500 pixels tall right there. Great, we're ready to go. Now, there's two bonus demos that I'm not going to talk through because there are better ways to lay out web pages than floats. And previous years, I went into these, but I archived them here so I can talk about some more exciting stuff a little later. But before we continue that, I want to talk about a concept called the box model. And the box model in CSS is, how do I determine the size of a box? If I have a thing and I say it's 250 pixels by 250 pixels, that's fine, it's 250 pixels. But then you're going to end up in weird situations like this where I have a map and that map is on the right and I have a sidebar and the sidebar's on the left. And this sidebar is 30% the width of the page and the map is 70% the width of the page. But I want my sidebar to have some padding. I want it to be separated. I want to pad it out a little. I want to see that. And let's do that. So you can see I put a little padding there. But where's my map? My map should be on the right side of the page. Well, not exactly, right? This is one of those concepts that people find a little confusing, is if you look at this in your dev tools, we'll pop that out real quick and we'll look at that. You can see that this is indeed 30% the width of the page, but if you look at this layout, this is the box model. This page, 30% the width of my page is 138-ish pixels, and then I have padding, and then I have a border, and then I have margin. Box model is how the browser measures things. So in this example, it's saying 30% the width of the page plus 1 rem on each side. Well, that's not exactly 30% of the page. It's 30% the width of the page plus 1 rem, which means there's not 70% the width of the page left for the map, so the map wraps down to the next line. That's a bit of a problem, but you can fortunately really fix that with a property of CSS called box sizing, which tells CSS to please change the behavior of how you laid out all your boxes. So this is the same problem, right? We have our sidebar, and we have our map kind of wrapping around the bottom. And I'm going to enable this box sizing property on here. And we can see it fixed it. Great. What the box sizing border box does is it tells the browser, hey, this width property, that includes padding and borders, please. So the 30% is now saying, including this padding, it should take up 30%, which leaves the 70% left for the map. So you can solve that problem pretty quickly. But even better than using floats and box sizing and those other tools is a relatively new thing that came out a few years ago, which all browsers support, called Flexbox. And Flexbox allows you to get even more powerful layouts with even less math. In this case, we have basically the same thing, except we've added a header and a footer now. So we have a header, and then we have a wrapper div that kind of contains our sidebar and our map, and then we have a footer. And if you look, we're saying, okay, the HTML and the body tag, those are 100% high. And you can see this is filling up my little demo area here. And on the body, instead of saying block or inline, we're going to say this is a flexbox. So all the children of that body element become boxes in this sort of stretchy, elastic box model. And we're going to tell those boxes that they should arrange themselves in a nice column. And then if you look, those are our wrapper, our header, and our footer, because those are the children of the body. 1, 2, 3. Sidebar and map aren't children, they're grandchildren of body, if we continue this awkward family metaphor. So the wrapper is going to flex. This defines how it stretches. And the 3 properties in order are how it grows, how it shrinks, and what its initial size is. So in this case, it's going to grow at a rate of 1 relative to all of the other things, the header and the footer, and it's going to shrink at a rate of 1 to fill the space. And it's just going to start at whatever size the browser thinks it should. But if you look at our header and our footer, they're a little different. They're not allowed to grow or shrink at all because both those properties are 0. And in this case, auto is simply saying, please become the smallest possible size. So when the browser loads this, it says, I have 1 element that I allowed to grow as much as I can, and I have 2 that I'm not. And it sizes all of them automatically for you. Now you can take the same process and do it in reverse. So on wrapper is also a flexible box. So wrapper is the contents of wrapper are also stretchy, and they'll stretch in a row. They'll stretch kind of left and right. And if you look, they're children of wrapper, sidebar, and map. And flex is 1, 1 auto, so it grows at a rate of 1 relative to the other things, and it shrinks at a rate of 1 relative to the other things, and you size it automatically based on that. And the map, however, grows twice as fast as the sidebar. So when the browser's laying all this out, it's going to give twice as much room to the map as the sidebar. And if you want the map to take up more room, you could just do something like change that to 3. You could change it to 4. You could change it to 5. You could change it to 6. And you can see that that proportion changes as you tell the browser to weight these different boxes in different ways. And that's great. And last year, I teased this a little bit. There's a newer standard that most browsers support, which is called Grid. And Grid is what an actual designer would actually want to lay out a page with, because it's exactly what they're taught basically in a design school. Turn this into a grid, please, is how we start. We have this structure. Now there's not even a wrapper div. We just have 4 divs, header, sidebar, map, body, footer, whatever. We have 4 divs, just 4 divs. And we turn those into a grid. Now grids have rows and columns naturally as a part of them. If I take a look at this in DevTools, and I hover over this grid, I can click it, and you can see it added, it's a little subtle. There's a purple dashed line, and it divides it into 6 boxes for me. And if I look at this grid property, oh, I can change the color, that's excellent. Display line numbers, areas, there we go. You can see that it's divided this body up into a box. This header now occupies this 6 cells of this grid. And we define those 6 cells like this. This grid has columns. So there are 2 columns in this grid. Imagine this like an Excel spreadsheet. There are 2 columns in this Excel spreadsheet, and there are 3 rows in this Excel spreadsheet. The first column is 33% the width of the entire spreadsheet, and the second column is just whatever happens to be left over. That's auto. The 3 rows are going to occupy whatever the smallest size is that the content will fit in, and the last row, which is our footer, is whatever the smallest size of box that will fit all the content. And then the middle row gets to take up everything that's left. And those are our 6 grid areas. You've got 2 rows, or you've got 2 columns and 3 rows. You've got 6 grid areas. 1, 2, 3, 4, 5, 6. So how you define the items in that grid is you just define what row and what column they start and stop at. So if you look at our header starts in the first column, and it spans to the second column, however many columns it needs to get to the second column. The footer does the same thing, but it uses this more complicated format where it starts in the third column, or it starts in the third row, first column, spans 1 column and 2 rows. And that just fills that bottom segment of it. The sidebar starts in the first column in the second row. And the map starts in the second column of the second row. Now, if that was a little confusing, CSS has got your back. And there's a bonus demo that I will show, which is you can name the areas of your grid. So in this case, I need to relaunch that. So this is exactly the same demo as before. We've got our 2 columns and our 3 rows, and then we added this new area, which is grid template areas. And you can see that we've actually named those 6 grid cells. We've created a small Excel spreadsheet inside our CSS file that says the header should be these 2 cells of our grid, the sidebar should be this cell, the map should be this cell, and the footer should be those 2 cells. And then, instead of all the complicated nonsense about spans and starts and stops and which row and which column, you just say, yeah, the sidebar should just go in the sidebar area. The map should go in the map area. The header should go in the header area. And this leads you to be able to do funny things like we can put our map in the header area and our header in the map area. And you can see that it just relays out the entire thing right there for you because it knows where those things should go, which area of the grid, and it knows how big each of the cells of the grid should be. So it just rearranges everything to work. Now, these 2 slides are great. I will point out 2 of the links really quick. Flexbox Froggy and Grid Garden are games that teach you Flexbox and CSS Grid. Think of them like Frogger with CSS. It's incredibly fun to load it up and play on the plane ride home, and you'll be great by the end of it. So continuing now that we've gotten most of our layout done, we're going to talk about margin, padding, and borders. And you've already seen a little bit of this. Padding increases the area inside the box. So padding is inside the border. So if you want something to have more background, like this header, you would apply padding. Here's some padding in the sidebar, some padding in the footer. In this case, we're using the rem. So 1 rem is about 16 pixels of padding right here. And then around this map, you'll notice I put map in its own little space. There it is. So map also has a margin. So the background of this container is this tan color, and the map background is this light cyan color. So the map has both a margin and padding. And you can see the padding encompasses the background, and the margin is outside it. So it pushes the map away from things. And a good analogy is think about this like pictures on your wall. The actual picture is this cyan area. The mat around your picture is the padding. How much white space do you want around your picture? The margin is how much space is there between this picture and the next picture on your wall. And you can see we're back to using Flexbox now. You can see Flexbox just handles all of this for you. The margin, the padding, everything is totally laid out, and it accounts for all of that without you having to really think about it. So we're going to touch really quick on responsive design. Now, responsive design means responding to the browser. And there's lots of different browser sizes. There's phones, there's tablets, there's small Windows laptops that might be tablets or laptops, and there's giant desktop computers. Being able to detect changes of what those are is incredibly powerful. And you'll see if I zoom out enough, I have two different layouts in this CSS. So on a really big screen, or when you zoom out absurdly far, this is the layout. This looks kind of like a typical map-centric layout. We've got a header, a sidebar, a map. But as I start to zoom in, as my screen gets smaller, you can see it rearranges itself. And that's due to a thing called media queries. And to start using media queries, you need to add a viewport tag, which tells the browser how to size this window on the device that you're on. In this case, we're going to say the viewport is always equal to the width of the device, which is the most basic bulletproof media query. And the bit that we added at the bottom is the actual media query. So we go at media screen. So when we're displaying this on a screen, and the maximum width of that screen, the widest that screen can possibly be, is 768 pixels, which is roughly the size of an iPad in portrait mode. Then we're going to change the CSS. And this is where those specificity rules come in super handy. Because remember how I said the last rule always wins? Guess what rules are declared last? All the small rules. So at this smaller screen size, we're going to change some of the properties of our CSS. Instead of laying out the wrapper around the map and the sidebar to go in a row, we're going to change it to go in a column. So the whole layout stacks vertically. And then we can divide the space between the map and the sidebar evenly. Remember how the map is always bigger than the sidebar, but now we can divide them evenly just by redeclaring the flex property. And these properties override the properties on here, even though the selectors are the same, because they were declared later in the file. And then we can say, start using the order property to change how these are ordered. Remember how sidebar was first, but now sidebar is second? That's the order property. We can flip the order without changing our HTML at all. And to show you that selector specificity, if I take this and I cut it, and I'll paste it back up here at the top, this all falls apart. Because even though the media query is true, it doesn't matter, because those properties have all been overwritten further down the page. But because we didn't declare order on our first set of styles for map and sidebar, you can see that those rules are true and they do apply, because there's nothing for them to there's nothing overriding them. They're still true. So the map and the sidebar still get flipped, but nothing else works. So finally, there's a concept in CSS for laying things out called positioning. And positioning is how you would typically, it's how the JavaScript API does all of the positioning of things over the top of the map. And this starts to get into creating layers. It's how you get zoom buttons at precisely the right spot, and how you layer the zoom buttons over the map. So to get started, we have our map, and you can see I've made these 4 little areas for controls. So the map has position relative. So I want to position children of this map relative to the top left corner of the map itself. That's what that says. And if you look at the control, each of the controls has this lovely light coral background, and they have some padding, and they also have this position absolute. So I want to position this absolutely to the corner of the nearest relative thing. And the nearest relative thing is the map, so we're going to position this inside the map. And then we have 4 classes, top, left, bottom, and right, each of which give you simply something that says right, bottom, left, top. And if you look at how this works in the actual HTML, you have a div with an ID of map, and then you have the 4 controls, and they have control, and then they have 2 of the directions, either top, bottom, left, right. And those properties all assign them a certain distance relative to this map. Now, you can, if I just comment that out, they become relative not to the map, but the nearest parent that is relative, which is the body. So now they're relative to the body, not the map. We can put that back. And you can also do other fun things with positioning. One of my favorites is I'm going to comment out these 4 or 3 of those. So we only have 1 left. And then we're going to say that top control is not only top, but bottom. And now it's 10 pixels away from both the bottom and the top, because the units are just kind of relative to each other. So if I also put left, 5 pixels, and I put right, 0 pixels, it now covers the entire thing, because that box has got to stay 10 pixels away from the top, 10 pixels away from the bottom, 5 pixels away from the left, and 0 pixels away from the right side. So you can use positioning to precisely position elements relative to other elements. And it's really useful for building things like map overlays. So we're almost ready to start building our app. We've got enough CSS knowledge, but we still need to get a little bit of design. And this gets into things like typography and color theory. And it's good to have just a basic grounding of those things for that. And some of the best resources that you can find, which is absolutely free for everyone, is Google Fonts. It's hundreds and hundreds of fonts that are hosted for you by Google that you can just copy and paste into your project. And it's as easy as this. Fonts, Google APIs, you don't have to actually memorize this. You just go to Google Fonts and copy this from somewhere, depending on what fonts you want to use. In this case, I'm using 2 fonts, Quattrocento and Oswald. And once those load, it's as simple as font family, and you say the font that you want. In this case, I want my body font, which is all my text, to be Quattrocento, which is this sans serif kind of looking font. And I want all of my headers, H1, 2, 3, 4, 5, and 6, to be Oswald, which is this very bold newspaper-esque font. And you can see that if I zoom out a little, there's some more text in that sidebar. That's got some nice styling applied to it. And I'll point out some of the other ones is, this is an independent project of Google Fonts, but it's a designer who's actually went in and created very nice looking pairs of fonts. So he suggests fonts, these 2 fonts tend to look really good together. So maybe you should make this one the header and this one the footer, and you can actually copy the code right from that page. There's also Font Pair and Font Tool Roundup, which are other similar pairings of fonts that tend to look really good together. So you don't even have to make the choice of, well, maybe I should use this font for the header. Just go pick one that you think reflects your project. So now we can talk about sizing type, because we definitely want our headers to be bigger than our other pieces of type. So an easy way to do this is where M's start to come into play really well, is sizing type. So we know that the default font size of a body is 16 pixels. So everything's relative to 16 pixels. So we want to put a bottom margin on all of our paragraphs. So if we have multiple paragraphs, like right here, they'll be separated from each other, which is nice. And we define 4 headers, so H1, 2, 3, and 4, they're all going to have some margin on the top, so a header will separate from the paragraph on top of it, which is right here. And they're all going to inherit some font weight, and they all have a certain line height. Line height is 1.2, which is relative to the size of the font, and then you can declare the sizes of fonts. So H1s are going to be 2.441 Ms, so 16 times 2.4. And so on down the line here. And if I change my body, if I say, no, I don't really like how all that looks, I want this to be slightly bigger, we can say that's going to be 20 pixels, call it font size. And now all the fonts are slightly bigger. So it's all relative to that base size. But how did I even come up with those, right? Those are very weird values to just pull out of thin air. Yes, I want my headers to be 2.441 rems, please. Those values actually came from a site called Typescale. And Typescale just gives you a visual reference for how to size your type. So your base size is 16 pixels because that's always what the browser is. And it even has the list of fonts from Google that you can pick from. So we know we're laying our headers out in Oswald. We know that they're going to be 400, which is the font weight. It's the regular weight. And you can choose these common type scales from designers. These are actually things that people did. This is how they determined the size of lead type back when printing was invented. So you can choose and you can see this maybe would be your 1, this would be your 2, this would be your 3, this would be your 4. That's a little ridiculous. So maybe we'll go here. This would be 1, 2, 3, 4, 5, 6, and your paragraphs. And you can get a nice little preview of how this actually might look on the side here. And when you're done, you can just copy the CSS, which is all printed neatly here for you. And you can just copy this into your project, which is exactly what I did for this demo. So then talking about color. Color is a little bit easier than type because you probably already have colors that your organization uses. You have branding colors and things like that. If you don't know what those are, just ask your designer or someone in your organization for the brand guidelines. They will be more than happy to talk your ear off. These are actually just links to a lot of websites that are kind of resources about color. There's a website called Flat UI Colors, which just has a bunch of color palettes that you maybe can pick from and lots of different colors if you're unsure. Calcite Web, which is our CSS framework that Esri uses. We also have a bunch of colors. These are our brand colors. This color pairing matrix is interesting, and I'll call it out specifically because it will tell you if different colors pass or fail accessibility standards. Accessibility standards indicate that you have to have a certain contrast ratio between the text and the background in order to pass most basic accessibility tests. So if I actually just close most of these, there we go, we can see that I have, if I'm using 4 colors on my web page, maybe this blue is a link color. But I can see that if I put that blue on a white background, it only has a contrast ratio of 1.56, and you can barely even see it on that monitor, and it fails accessibility. But if I put that blue on black, it's AAA, which is the web accessibility AAA standard, which is the best standard for color contrast. So if I want to find this color that works well on light, maybe I can make it a little darker. And then I can pass AA, and then I know that color is safe to use on a web page for accessibility. So that's a good tool to keep in mind. There's also things like Adobe Cooler, which is a color wheel picker. You can just kind of drag this around and get a little color palette. And you can choose different themes, like getting different shades of a color. Compound is fun. And this is so you can quickly generate maybe some color combinations for your app. And after making some color choices, we can get our app to look like this. I generated this out of some of those flat UI colors, and I confirmed the color contrast works for everything. So we have this dark blue background and this very, very slight gray text that might just honestly look white to you. And then we have these colors, some separate colors for the links, and you just apply that with things like background color and background, and there should be a text color is just the color property. So the background is this navy, and then the actual color is, ECF0. You just don't even pay attention, just copy paste, please. And so you can just define the colors once you get those hex values. So the last thing I want to do is actually just show how this looks with just a little bit of JavaScript in it. So this is our final demo. Right? There's just a little bit of JavaScript that I snuck into this third tab, which just creates a base map and does some other stuff. So we need some stuff from the JavaScript API. We need map view, feature layer, and we need the search widget. We make a new map. It's dark gray vector. We make a new map view. We point it at our map container, which is right here. And then that just fills that div with the map. And you can see that this is actually, it looks pretty good for just being only, say, 120 lines of CSS and 30 lines of JavaScript. It's 150 lines of stuff to make this, which looks really good. And when you break it down like that, this is really simple to just produce something super fast that works. And this year, there's also a bit of a bonus. I did the same thing with CSS Grid, which is actually even less lines of code. And you can see this is the CSS Grid version of the same demo, done with the grid template columns. So that's about it. That's 120 lines of CSS, 30 lines of JavaScript. You can make that little app right there, applying some of these basic principles and modern layout techniques and things like that. So to close, I do want to address browser compatibility and how you can start to think about it at least. Modern browsers are incredibly standards oriented. They all implement very, very high levels of adherence to the standards. So the two biggest sites that you would want to use are things like Can I Use, where you can just type in the name of a feature that you want to use. Like, you know, can I use that Flexbox stuff Patrick showed on stage? Yes, you can, because it's green everywhere, except over here in Internet Explorer, where, you know, it's kind of gross looking. And you can hover over it and it'll tell you partial support is due to a large number of bugs, see known issues, and you can click on known issues and it lists all the known issues. MDN is the Mozilla Developer Network. It's Firefox. They have a complete reference for CSS. And as you go through, you can find, I'll find a thing here. You can go through and look at things, and they will have, here we go. On the specific property page, it'll have a browser compatibility table at the bottom, which tells you where you can use that property across all the different browsers and exactly what that property does and everything else. I am going to show you one tool, which is Auto Prefixer, because a lot of browsers experiment with their implementation of the standard by adding a prefix. So if you want to experiment with the Firefox version of Grid, you could say Mozgrid instead of Grid, and that'll only enable that for Firefox. So tools like Auto Prefixer have eventually popped up, which automatically add all of the prefixes for a given set of browsers. And I'm going to link you to the online version because it's probably the easiest to understand, because you just paste in your CSS on one side and you copy out the fully prefixed CSS for the last 4 versions of every major browser on the right side. So you can see that we said we want our example to be display grid. And it not only put in display grid, it also put in display MS grid from Microsoft Grid for older versions of Internet Explorer. And it did all that for us without us even having to worry. So this is even just a great tool. Write your CSS, paste it into this, copy this back out, and then you probably support maybe IE11, which you really shouldn't even be using because Microsoft killed it 2 years ago. And you should go tell your boss. Because it's also not getting security updates. So now it's actually a liability. And the faster we can get rid of Internet Explorer 11, the faster we can all live happily, where browsers actually update all the time and support the latest standards all the time. So in closing, these are some tips. Keep your selectors really, really simple. Across all these demos, I maybe used a few IDs, a few classes, and a few tag selectors. I didn't combine them at all into more specific things. You can get quite far with it being very simple. And by keeping room for it to be very simple, you also leave yourself room to be more specific later, which is really good. Again, like the JavaScript talk, don't use tools until you're really familiar with the basics. Auto Prefixer might be the one exception because it's just pasted in one side and copied out the other. But there are lots of CSS tools. There's lots of CSS frameworks we built a great looking app and 150 lines of code. I don't think you need them to get started. But once you start to build bigger apps, it becomes slightly more useful, and you might want to think about using them when you start getting really into this and building bigger and bigger things. In that line, don't actually worry so much about browser compatibility. When you're just learning, it's easy enough to just say, I want everything to look good on Chrome, Firefox, and Safari, and maybe the latest version of Internet of Edge, right, the new Microsoft browser. That's good enough. Internet Explorer accounts for maybe 2% of worldwide traffic. It's not highly used. So when you're just learning, don't pay much attention to that. However, when you do the web fonts route, don't pick 20 fonts from Google Fonts, because the browser has to download all of them. And fonts are actually rather large. They tend to be about as large as a large photograph. So think about how slow like a large photograph loads on your phone. And then imagine that for every font you pick. Usually just pick one, maybe for the headers, maybe two. And then this next one, I added this year, avoid using floats. We didn't cover floats too much because floats aren't really used for laying out web pages anymore. Grid and Flexbox are definitely the standard, especially Flexbox, because Flexbox is really nicely supported across every browser. So it makes an ideal candidate to learn CSS now. And then finally, you can do a lot with Web Inspector. You can just go to a page, right-click on it, hit in DevTools, look at the CSS, figure out how things are put together. You can learn a lot just by poking around with the DevTools. That is all I have. Grab the slides link right there one last time. I'll go back to that in a sec because I see some photos. So I do want to say, please fill out the feedback for this session. It'll keep me going for next year when I think about not doing it anymore. So that is the link to the slides. There's the standard, please take the survey. It's in the events app. Go in and fill it out. And I'll leave this up here in case anyone wants to grab the slides. Thank you. We've got about 10 minutes for questions, and I'll stick around for another few minutes after that. So any burning questions? Yeah. So the question was, is it better to start out designing for small screens first and then build up to larger screens? There's kind of two schools of thought on it. So I work on the developer's website, and if you look at our Google Analytics, 95% of people visiting the developer site are on this, more or less, for a screen size. So it's not economical for us to design at a small size first when it only works for 5% of our users. So we start on the developer site at a large size and go down. Maybe you're working on a mobile app, start at the small size and work up to the tablet size and then work up. So it depends on your use case. If you're building, mobile apps or web pages to display on phones or tablets, definitely. You can start designing for the smallest size first and then go up from there. And I'll point out, this is excellent. This is in Firefox. If you're in Inspector, there's this nice little button. Chrome has this too. You can go into responsive design mode, and then you can pick different phone sizes. So that one doesn't look very good. So for example, this is an iPhone X and XS phone size that I just resized the web page to. And it's kind of fun. So you can actually preview in your browser without actually going to your phone and fiddling with it to apply that, which is a really nice feature. But yeah, it depends exactly on your use case. You can start writing for smaller screens first and build the sizes up. I've found it easier to learn and teach at the desktop size and learn down. But it's definitely kind of a matter of what you're building. Anything else? Yeah. Darn. There is the link. Oh, that is a little small. That is the correct link. 2 capital C, capital F, 5 lowercase k, uppercase Q, lowercase w. Thank you very much. These are also available. These go out as a PDF too afterwards in the proceedings. So you'll also be able to grab it from the proceedings site in about a week or so. So I'll leave that up for now. Actually, yeah, I'll leave that up for now. And I saw over there. There is. So the question was, is there something like variables for colors? Because you're going to clearly use the same color everywhere. There is. It's relatively new, so I didn't cover it because it's not super well supported. If you want to Google CSS variables, that's what it's called. It's a way to have that kind of variable-like system in CSS. A lot of the tools, like if you look at tools like Sass, will also do that too. If you want to get into the tooling part of this a little more, for simple apps, it's honestly just as easy to do find and replace though. If as soon as your CSS starts getting across multiple files, that's when it starts to be a little bit more of a pain to say, I want to replace the text color everywhere, but the text color is defined in 4 different files. So there is a way, but I will warn you, I didn't cover it because it's not supported broadly by a lot of browsers. Is there any other questions? Nope. Okay, I'll be up here for a couple minutes. Thank you.